This is not on your paper. We're going to go through it together. I really need y'all to give me your attention. Okay, letter C, is that growth or decay? Growth. Growth, why? Good. The second value is our growth or decay factor, and since it's larger than 1, it's growth. Letter D. Growth. Letter E. Growth. Okay. There might have been some confusion with ones like this because you're used to seeing 2 values. The growth factor is 2, and the y-intercept is 1, because if I multiply this by 1, it doesn't change anything, so you don't actually have to write it. It's like the assumed coefficient on a variable is 1. So the y-intercept is 1, the rate is 2. Letter F.
That's
Decay. 9. Decay. All right. So now, your notes. An exponential function is a function in the form a times b to the power of x, where the base b is a positive rational number other than 1, and the exponent x is a variable depending on what you're trying to solve for, right? So that x can change. You interchange that out. When the base value b is greater than 1, your function is an exponential growth function. And if your base value is between 0 and 1, the function is an exponential decay function. And they have the same relationship as a geometric sequence, right? Geometric sequences, except you can't have a negative growth or decay rate, okay? Because you can't, when you graph and they alternate positive, negative, then it wouldn't make that curve, right? Okay, so graphing exponential function, 3 times 2 to the power of x. Let's fill in some information that we know just by the equation. What does my equation tell me? Okay, the factor is 2. The y-intercept is 3. Is it growth or is it decay? Growth. All right, so now let's use our calculator to get more information. Okay, open up a new document. New document, add a graph, and type in your function, 3 times 2 to the power of x, enter. Okay, so that confirms that yes, it is a growth function, increasing, and I need my table of values, so I'm going to push Control T, and my table on my paper starts at -2, so 0.75. 0.75, bless you. What's -1? 1.5, what's 0? 1 and 2, 12. Okay. So my function is increasing, but what happens if I move to the left? What's happening to my function towards the left-hand side?
It's getting smaller.
Smaller and smaller and smaller and smaller and smaller and smaller. if you look back at your table, if you keep going up, what are your values getting close to? It's getting close to 0, but it's never going to actually reach 0. Good. So there's kind of a boundary, per se, at this line. Would y'all agree? I could draw like a boundary line at y equals 0. Okay. So now that line that I just drew on my graph that your curve is approaching but never reaching is called the horizontal asymptote. My horizontal asymptote is always an equation of a line. It's an equation of a horizontal line, so it's always y equals, and it's that line that your curve is approaching. So in this scenario, my horizontal asymptote is y equals 0 because my curve is approaching 0 but will never actually reach it. No, because it's a horizontal line.
Oh, okay.
So what's my domain? All real. What's my range? Y is greater than 0. Good. When you are looking at your horizontal asymptote and your range, your values should match. Okay? So the value from your range and the value from your horizontal asymptote should match for your functions. Okay, let's look at another one. 2 times 1/2 to the power of x. What do we know just from the equation? Decay. What's the decay factor? Half. What else do we know? The y-intercept is 2.
And y is less than 2.
Well, let's wait on that for a second. Okay, so now let's get all the other information that we need. We are going to open a new document, not save. Enter a graph, 2 times 1/2 to the power of x. Enter. Okay, confirmed, it's decay. I'm going to Control T, get my table. I need it to start at -2. So the -2 value is 8. What's my -1? 4. What's my 1? 1 and my 2. 0.5. Okay, so as my function, as x increases, what does y start getting closer to? 0. So I'm going to draw my horizontal asymptote. Y equals 0. What's my domain? All real. No. What value is your curve approaching but never reaching? Or what value? 0. No.
How do you know if it's not 0?
If my curve was down below,
Oh,
so let's say that 2 to the power of x minus 3.
Then what would it be?
Negative 3.
Negative.
Like,
Oh.
Okay.
so my line would be right here. My horizontal asymptote would be y is equal to negative 3. But that also means that my range would be y is greater than negative 3, right? So that range value kind of helps you double check what you have. So what's my range? Y is greater than 0. Very good. Y'all try the last one on your own, and we'll check together in a minute or two. So, the last one, growth or decay. What's the factor? Is it 3?
Now,
Yeah. Okay. 0, 4. What's my horizontal asymptote? Y equals 0. What's my domain? What's my range? Y is greater than 0, and you should have 4, 4/3, 4/9, 12, 36. I mean, they could. Okay, so you have time left in class. I have a couple people that I need to get to make up some egg tickets so I can get all that finished up. You guys have time to work on your homework. Assuming that you are working until the end of class, you probably shouldn't have any homework by the time the class is over.